Hi everyone, welcome to my talk. So before I'm drilling down to statistics, I want to show you what does it mean to have security in Kubernetes at all, because what we've scanned is in the matter of security perspective and not just in general, of course. So Kubernetes is now de facto what is called the new cloud native operating system, and that makes it a lot of companies. We see that 96 of the organizations are using Kubernetes, and we see it's growing over the years. And like in this year, mainly a lot of adoption of Kubernetes. Mainly this is because it's, I would say, the only orchestrator available today that has that is managed and everyone is fully aware of. So having said that, the Kubernetes is the operating system. What do we need to do? We need to secure our operating system because attackers don't no longer see it off the radar. They do try to bridge into Kubernetes. We haven't seen any major bridge, but we do see a lot of tries and we see a lot of documentation on that. But still, it hasn't happened yet. Hopefully it won't happen at all, but we need to secure ourselves in that case. So what we also see in that matter is that everyone is approaching to the security persona in the organization, to the CISO or security manager. But what we do see is that he is not responsible anymore for security when it comes to Kubernetes. So we do see that the person who is responsible for security when it comes to secure your cluster is the DevOps, right? We can see it right here at the right. So the DevOps is responsible for the security, DevOps, DevSecOps, any ops persona is responsible. And we do see it comes in often cycles, like releasing weekly releases. And they are using Kubernetes specifically to improve the scalability. We're using Orchestrator because we need to improve the scalability, and also we want to decrease the development time. So those are the major points of why even using Kubernetes, and who is basically the Kubernetes security role in your organization or in any organization. So Gartner checked that and said, why do we even need any Kubernetes security at all, right? Because I'm often hearing that, okay, oh, I'm on Kubernetes, then all good, I'm secure, great. That's wrong. We do see that DevOps are telling us that, or telling Gartner that the security incidents and issues into their Kubernetes cluster are mainly into detected misconfiguration, like they misconfigured or the YAML are default values, sort of things. And on the other hand, what they're worried most is CVEs in images, like vulnerabilities, and again, misconfiguration that can expose to, let's say, outer network, and so on and so forth. So having said that, we have two paradigms of how to protect Kubernetes. So the first one is what we're calling Kubernetes posture management. The second one is the runtime protection. So the posture management is to find known vulnerabilities and misconfigurations, something that we know in advance. But the runtime protection is like anomaly behavioral analysis and network segmentation. We don't know it ahead of time. So what do we focus on is, in one hand, shrinking the attack surface, and we can detect the posture management early in the CI/CD pipeline. And when coming to runtime protection, then we want to assure and actually take an action upon detecting in runtime if attack has happened. So in order to drill to the numbers and statistics that we calculate and got, then we needed Kubescape, which is Armo's open source for Kubernetes security. The architecture is pretty simple. Kubescape as a whole is an open source solution. It gets from the cluster the vulnerabilities and the configuration issues, also from the Git repository and container registries, but we won't focus on that time. And eventually it sends all the data to ARM platform. ARM platform is where I can see all this data in a very nice way. I mean, UI visualizing way, but also that's where I'm storing the data and I can analyze that. So I will talk like a bit about Kubescape because that's the tool that got us all this information and what we've learned from scanning with Kubescape. So Kubescape really became like the majority of tools, most popular tools in security, open source security tool for Kubernetes. And it got really high like lately. And what we see here is, remember saying that we need the posture management and we see the runtime management. So here is part of that. We can see the risk analysis and compliance. We can see the RBAC visualizer, like what are the roles and responsibility, a visual graph of your RBAC in the cluster, and of course the vulnerabilities coming along the way in your images. So we're talking mainly about the CI/CD pipeline. So we need to check everything at the early stage of the CI/CD because we don't want to get into the cluster and realize that we're having some misconfigurations, right? So let's check things ahead of time in your repositories, in your registries, across the pipe before getting into the cluster. But when we're in the cluster, we need to verify that we don't have any misconfigurations there, of course, but we will like to take the other step of runtime zero trust. So it's super easy to install. It's just a help chart. Just run the command and you can see it all in the GitHub. Very easy, and of course CNCF sandboxing recently, so you can see it right away. So after having this understanding of what we gathered, right, and how we gathered this data, so now what we're learning from that. So as said before, what is the user title of those people in the cluster? Like, I think around 60%, even more, like 60, let's say a bit more, are DevOps. So DevOps is the security persona that we defined in the data we collected from the clusters. And the region is like around North America is half, Europe is around third, and all the rest. And like, let's see another overview of what data do we have. The number of clusters. Most of the users has one cluster. 33% has like between 2 and 4. And the cluster size, I mean, how many nodes are in this clusters? 34% are less than 5, and 33% are between 6 and 10. There are, of course, some beyond 50, but of course, it really depends on the environment they are scanning. So what have we learned? In Kubescape, we're scanning by framework. We're scanning the NSA framework, the MITRE framework, the Armor Best, and the DevOps Best framework. And the average score per framework is around 30%, and the score that is lower than 30 is an okay score. Okay, beware, you can check your own score with Kubescape and see in which framework, in which compliance framework is the score available. So the top 5 misconfigurations are run privileged container, cluster admin bindings, missing resource policies, immutable container file system, and ingress and egress blocked. So what we do see here is 100% had at least one misconfiguration, and 65% had at least one high severity misconfiguration, and 50 of the cluster has more than 14 failed controls. Controls are the substitute of the framework I talked before, and those are the misconfigurations that we are testing and finding. So let's drill down a bit to what we see. So running privileged container is a big no-no, and we can see the basic of what users are running, and if you are putting some data into the pod spec, then we see it's not privileged, right? We can see that in the security context, if you run in this user that is greater than 999 and the runners group also will be greater than 999, you're pretty much safe. But you also need to have the allow privilege escalation as false. So, privileged container will run in your pod. Okay, that's a big bridge into your cluster. You can check that out also in a blog that Bandasi Armo just wrote. So the next thing is we talked about 63% of clusters that has some workloads that are exposed outside the cluster without any ingress block. So of course, we do need to check those data. You need to check the ingress. And in Kubescape, we do check that. But look how many cluster, and look at this percentage. That means that the tunnel out is clear. And also, the 63, again, percentage of the cluster had workloads without proper resource limitation. So if you don't have resource limitation, then each container can take as much resources as he wants, right? You can take the entire cluster resources if he needs. And that is not just a developing problem, but also it's a security breach. And 37 of the cluster has like application with credential and configuration file. So it's so easy, to say that, but we do see that going and repeating all over. We're checking for password word. We're checking for JW2. We're checking for private key. All those kinds of phrases are still available in the configuration files. And 23% of the cluster had like application running with dangerous Linux capabilities. And that's like basic, because also if you're running on VMs, then we need to harden our application. So again, it's not just related to Kubernetes, it's just manual thinking. Also previously, when talking about passwords and all those other phrases, then it's super easy to check and also to solve. So 35% of the cluster had workload running with insecure capabilities. So we're checking both of those things, and together we see like it's majority of clusters. So if we will take a look now onto the vulnerability part of the cluster, and we checked for vulnerabilities, we can, it's a good thing to say that cluster has 0 critical vulnerabilities, but they do have 1 or 2 17% critical vulnerabilities, etc. Again, that's a breach. So if you have any critical vulnerability, is mandatory to fix, especially if it's a remote code execution one. It's a super important one. And the vulnerability by severity, again, is just another view of the critical and high and medium and low. So the top 5 vulnerabilities we found, I've seen here. And what is interesting that 63% of the container had 1 or more vulnerabilities across. And 46 of container had one or more critical vulnerabilities specifically. And we talked about RCE, remote code execution, that we see 53% that container had like one or more RCE vulnerabilities. All that we learn, from scanning just this 10K cluster. This is the information about the critical vulnerability, glibc, of course, and libcre. There were very well-known CVEs. You can read about it also in this blog. It's super detailed about the container escape vulnerability and its impact on Kubernetes. I must say that we will get into it in the next talk, but when I'm thinking about what we've really learned and what are the conclusions that I'm taking, from that talk is that, most of companies already run like Kubernetes clusters, and security is a big, big pain, but no one's really wants to deal or handle it. And if you're taking it to the security persona, he says, no, go to the DevOps. And if you're taking it to the DevOps, then he said, no, go to the security persona. It's something that we should combine together, and therefore we see a lot of DevSecOps operation now. And as I said, DevOps are the new security personas. So DevSecOps is the new phrase. And, we are overwhelmed with misconfiguration and vulnerabilities. We do see it's a big problem. And here in Armon, we are trying to figure that out with relevant vulnerability specific for the cluster, whatever runs in runtime and not just detected in previous states, whatever is really, onto the memory at the time. And this will be continued, and we will show it next talk. So thank you very much for being with me here today. It was a pleasure. And again, thank you.